Okay, so for this video, we are going to discuss May-June 2022 or Summer 2022, Paper 1-3. Right, so we start with the first question. Okay, so first question, they are saying that the coefficient of x power 3 in the expansion is 144. So for this one, we need to expand it. They want us to find the possible values for the constant of p. Okay, so this is basically binomial expansion. Right, so for binomial expansion, the general formula will be n c r, then the first term power n minus r, and the second term with the r. Right, so if I try to apply in my question here, okay, so this is a general formula. Right, so if I try to apply this formula in my expansion here, basically I should have 4c something. First term is a p power 4 minus something, and also 1 over p x power something. Okay, so I need to try to analyze because I want to have x power 3 in my expansion. Therefore, for this particular term, the power must be a 3. So that eventually I will have x power 3 when I try to expand it. Okay, so if this is a 3, the other power will be actually the n minus 1. So my n is 4. So 4 minus 3, you get actually a 1. Sorry, it should be 4 minus 3. So it will be 1. And then 4c3, because our r here, okay, is a 3. Alright, so after I write out the formula, the general formula for this binomial expansion, okay, so I try to simplify it. When I try to simplify, I will have 4 over p squared and then x power 3. And for this question, they actually mentioned that the coefficient of x power 3 is 144. And for our expansion here, the coefficient is actually 4 over p squared. Therefore, I try to compare the 4 over p squared with the value 144. Okay, and my p squared, I should get 1 over 36. And when I take square root for both sides, I will have plus minus 1 over 6. So this will be the values for p. Okay, so we come to question number 2. They give us a diagram, and then it is actually part of the graph y equals to p sine q theta plus r, and p, q, r are constant. First question, they want us to state the value for p. Okay, so to find the value for p is a multiplication of a number outside the sine function or sine graph. Therefore, it will actually affect the height from the center line of the graph to the maximum, and also the center line of the graph to the minimum point. Okay, so to decide the value for p, I need to figure out where is the center of the horizontal line for this graph. Okay, so if you try to analyze it, you will realize that this is the center. This line basically is the center of the sine graph. Okay, and then original sine graph is having amplitude 1, where from the center to the highest point, okay, the unit should be 1 unit. But if we try to observe this diagram, you will see that from the center to the highest point in the graph is actually 3 units. -1, 0, and 1. There are 3 units here. Same thing happened for the minimum point. If you try to observe the center line to the minimum point here, it is also 3 units, right? Which means that this particular value of p will actually affect the amplitude, we'll say amplitude, okay, for the sine graph. Therefore, from here, we'll know that p is actually equals to 3. Okay, so part B. Part B, they ask us to state the value for Q. To decide the value for Q, if you try to observe, Q is actually in the function sine. Therefore, Q will actually affect the number of cycles that appear in a given range. Alright, when we are having sine theta, if we are having sine theta, that means from 0 until 2 pi, we are having 1 cycle of sine theta curve, which means that we will have 1 cycle like this from 0 until 2 pi. if let's say we are having sine 2 theta, basically it means that from 0 until 2 pi, we are having 2 cycles of the sine graph, where we will have 2 cycle and the ending point here is 2 pi. This one, the ending point is 2 pi as well. Okay, so basically the value of this number inside the sine graph, inside the sine function, it will affect the number of cycles that appear in 2 pi from 0 until 2 pi. Okay, so to decide the value for Q, I will need to observe how many cycles appear from 0 until 2 pi. So you can say this is 0 and this is 2 pi, right? Okay, so from 0 until 2 pi, you will see that we don't have one complete cycle for the sine. We only have half of the cycle, half of the complete cycle of the sine. Therefore, the value of Q here, we know that it is equals to half. Only half cycle, right, from 0 until 2 pi. Therefore, the Q will be equals to half. Alright, and last one, they ask us to state the value for R. Okay, so for R, basically you are seeing that they are having a plus R outside the whole function, whole basic function for sine graph. Okay, basically for plus R, you should know that it is actually a translation in y-axis. To figure out the value for R again, we actually need to know also where is the center line. So again, this is a center, the horizontal center for the graph of sine, right? The original center for the sine graph should be at 0 at the x-axis, and you will realize that they are moving the center line 2 units downwards. Alright, so this is the original horizontal center, which is the x-axis, and now you can see that the horizontal center line become -2, which means that they are trying to translate this whole graph 2 units down, okay, in the y direction. Therefore, from here, we will know that the value for R should be equals to -2 because we are moving it down. Therefore, it should be in the negative direction. So negative, going down is negative, so -2. Okay, so this is how we use the diagram and help us to analyze and get these 3 values for P, Q, and. We come to question number 3. It is given that we have an arithmetic progression where the first term is a 4 and then common difference is D. The sum of the first n term of the progression is 5863, and they want us to show this equation. Right, so before we start, we are having arithmetic progression, right? So what are the formula that related to arithmetic progression? There are a few. So maybe the first one will be the n term. If we are having the formula for n term for arithmetic progression, it will be Tn equals to a plus n minus 1d. And another related formula will be the sum of the n term. So for the sum of the first n term, it will be equals to n over 2, 2a plus n minus 1d, where the a should be the first term. Alright, so basically this is the formula that usually we will use when we try to deal with the arithmetic progression question. Right, then now if we go further and have a look for the details in the question, they are giving us that the sum of the first n term is 5863. Therefore, I need to apply this formula, sum of the first n term, and try to substitute the value a equals to 4. First term is a 4, right? Substitute a equals to 4. Try to rephrase it, and I hope we can get this. Alright, so we will start. Our general formula will be Sn equals to n over 2, 2a plus n minus 1d. The value for Sn is 5863. And what I know that the value for a is a 4. So 4 times 2, I will have 8. I think it is quite easy that if you try to rephrase everything here, I will have 11726 over n, and if I try to move the 8 over, then I will get the answer they want us to show successfully. Okay, so basically we just try to rephrase the sum of the first n-term formula into this pattern that they want us to show. Okay, and then we can proceed to the part B. For part B, they are saying that we are having the n term. N term is 139. They want us to find the value of n and d, and then the d must be rephrased in the fraction form. Okay, so this one, n term. N term will be related to this formula, Tn equals to a plus n minus 1d. So I will try to substitute my information into this formula. Alright, so start. Tn equals to a plus n minus 1d. I know that Tn value is 139. I know that the value for the A is a 4. If I try to rephrase it, I will have n minus 1d equals to 135. Okay, so if I try to compare it with the equation that I get just now, you will see that first equation, if I assume that this is the first equation, basically you can see that the first equation I'm having n minus 1d. For the second equation also I'm having n minus 1d. So to solve for the value for n and d, right, I need two equations, and I'm having these two equations now. To get the value for n or d, you can just try to solve these two equations simultaneously. Right, so I will let equation number 1 equals to equation number 2, where you will get 11726 over n minus 8, it is equals to 135. Then if you continue further, of course you can get the value for n, where it is equals to 82. And now they want us to get the value for d. To get the value for d, I will try to get it from this particular pattern that we have here. Okay, or maybe equation number 2. Okay, so maybe I'm using this equation number 2. This one. Okay, so I will substitute the value of n into this equation number 2, where I will have 81d equals to 135. Therefore, I can get my d in terms of fraction. So I'm having 135 divided by 81. And of course, you can try and see whether I can simplify it further or not. Eventually, we'll get actually d equals to 5 over 3. And this is the value for the d in the fraction form. And the value for n should be equals to 82. Alright, so this is how we solve this question. We are at question number 4 now. They give us a curve with this equation, and then we have a transformation or translation. Alright, -1 and also 3. And they want us to find the equation of the translated curve, giving your answer in the form of this as a final answer. Okay, so for translation, right, if I want to move the x 1 unit to the left hand side, and when we want to adjust the equation, we should move back the -1, where it will become x plus 1. That means I have to substitute my equation, all the x with x plus 1. For the y value as well, for this one, basically we are trying to move y equals to 3 units, that means 3 units up. But when you want to get the translated curve, we want to move back the 3, where I will get y minus 3. That means in the original formula or original equation, I need to substitute the y by using y minus 3. Alright, so if I try to express it out, this is my original formula. So you can try to observe. If I want to substitute x and y by using y minus 3 and also x plus 1. So I will have x plus 1 squared plus 2x plus 1, then minus 5. Okay, try to expand everything and simplify it, because they want us to have the answer in terms of ax squared plus bx plus c. So we will have x squared plus 2x plus 1, and then 2x plus 2 minus 5. And if I try to simplify it further, then I should have x squared plus 4x, and then 1 plus 2 is a 3 minus 5 is 2, minus 2 plus 3 is a 1. So I should have y equals to x squared plus 4x plus 1. So this is actually the translated curve. Okay, after the original curve, go through the translation. This is a translated curve formula or equation. Okay, so we can proceed to part B. For part B, they are saying that we are having this curve again, all right, then it's transformed to a curve with this equation. And then they want us to describe fully the single transformation that has been applied. I think the single is an important word. When you try to transform the original curve to this one, they only want us to state for to apply, okay, to have the transformation in one step. Okay, only one transformation is allowed. Okay, so we have to try to observe it very carefully. First of all, we look at the constant. So you can see the constant has not changed. Right, it is still remain the same, which is -5. Alright, so basically you will see that somehow maybe translation does not appear here. Okay, we might exclude it first, although it might have the possibility that we get the translation, but we try to put it aside first, and then we try to observe all the term for x. Okay, from x squared, how can I have 4x squared? There are many ways that from x squared you can have 4x squared. So if we want to try and compare 2x with 4x, okay, you realize that from 2x to 4x, right, we actually times 2. So for x squared to 4x squared, basically times 2 squared. So if you try to observe, right, you can see that the original x, if I substitute it by using 2x squared, then I will have 4x squared. And for the original 2x, right, if I substitute the x by using 2x, then I'll get 4x. And you can see that for the constant part here, basically it will not be affected. Okay, so some students say, can I like try to think some other way? Of course, you can try to analyze it, but the main idea that I get, this idea is from this 2x to 4x. So I will try to think how to change the 2x become 4x, and I want to keep the 2 in front, and then x substitute by some other thing. So by analyzing this way, you know that 2x is the value, or maybe is the term that I should substitute inside the original equation. Right? Okay. So when we are having x squared become 2x squared, what kind of transformation is this? Okay, so basically it is like this. If I try to rewrite my original equation become x squared plus 2x minus 5, okay, and I will realize that if I substitute 2x inside my function f, then I will have 2x squared plus 2x, then minus 5, where I get 4x squared plus 4x minus 5. And this is a transformation that we have when we multiply a 2 inside the basic function. Okay, so we call this transformation as a stretch in x direction. So I can write it out in this way. There's a stretch in x direction, and we should try to mention what is the stretch factor. So with a stretch factor of half. Okay, basically for the stretching in the function, right, when we are having the stretch in the x, the value itself for the stretch factor should be opposite meaning. That means when you multiply a 2, okay, inside the function, when we interpret it outside the function, it should be 1/2 basically. Alright, so this is the single transformation that has been applied to the function fx or the equation y. Question number 5, they want us to solve this particular equation. Okay, so for me, before I solve it, right, I feel that this square root y is quite complicated when I look at this particular equation. So to make it looks more simple, maybe we can let x equals to square root y first, and let's see what do we observe after we change it. Right, so I'm having 6x plus 2/x minus 7 equals to 0. So I don't like to have the x as a denominator. I will multiply the whole equation with x. Then from here, I think it is quite obvious that you can see we actually get the quadratic equation. Okay, to solve for the quadratic equation, you can factorize it. So that I have -7 in the center. Then I will have two values for the x, where x can be equals to 2 over 3, and also x can be equals to 1 over 2. But of course, this is not our final answer because we already changed x become square root y, right? We have to substitute back the square root y into my solution here. Then continue further to get the answer for the y. So to get rid of the square root, I will square it, where I will have 4 over 9 and also 1 over 4. So that means you square both sides to get rid of the square root. And my value for the y will be 4 over 9 and also 1 over 4. This is what we have for part 1. Then now if we go to part 2, part B, hence. So that means continue from the first question here. They want us to solve the equation of this. And then the x should be from 0 until 360. If you try to compare this particular equation in part B with the equation in part A, if you can't compare it directly, so you can see that y is equals to tangent x. Right, so you're having square root y here, and then at the bottom you're having square root x, square root tangent x. Therefore, you know that y should be equals to tangent x. When I try to solve the equation on the part A, I get two values for the y, where it is 4 over 9 and 1 over 4. And in part number 2, I can straight away substitute the y by using tangent x. So tangent x equals to 4 over 9. Tangent x equals to 1 over 4. And we want to solve for the value of x. To get the value for x, first you can try to find out the basic angle first. For this particular solution, this particular equation, the basic angle that we get should be 24. For the second equation here, the basic angle that we get should be 14. Okay, so how to get the basic angle? Basically, you bring tangent over, become tangent inverse 1 over 4. Okay, then you can get the basic angle. Alright, then the same thing happen here. To get a 24, you take tangent inverse 4 over 9. Then you get 24. After you get the basic angle, then we need to go through the quadrants and see which is the answer from the quadrant that I want to accept. Okay, so for 4 quadrant here, I'm having first quadrant, everything is positive. Second quadrant, sine is positive. Third quadrant, tangent is positive. Then the fourth quadrant, cos is positive. To get the angle from the different quadrant here, basically the formula is first quadrant will be the basic angle. Second quadrant will be 180 minus the basic angle. Third quadrant is 180 plus basic angle, where the fourth quadrant is 360 minus the basic angle. So now I want to go through the quadrant to get for my answer. Okay, I'm looking for tangent with a positive value. So in which quadrant tangent is positive? So you should go through all the quadrant first. Start with the first quadrant. Tangent is positive, therefore I want the answer from this particular quadrant. And the value of x that I get should be 24, which is the basic angle. Second quadrant, sine is positive. So I don't want to answer for this particular quadrant because I am looking for tangent positive. When I come to third quadrant, I realize that tangent is positive and this is the answer that I want from this quadrant. How to get an answer from this quadrant? You take 180 plus the basic angle. So 180 plus basic angle, by right you should get 204. Okay. Then next one, the fourth quadrant, cos is positive, therefore we want to ignore the answer from this quadrant because we are looking for tangent positive. Okay, so we have done for the first part here. Then now we proceed to the second equation. It is also tangent positive and the basic angle is 1 over 14. So I think we should try, since both equation, right, we are having tangent positive. Therefore, you should get the answer from the first quadrant and also the third quadrant. For the second equation here, again, the first quadrant answer basic angle is 14. So the answer will be 14. Then for the third quadrant should be 180 plus basic angle. So 180 plus 14, it will be 194. Okay, so we ended going through all the four quadrants already. Then usually for me, I will try to write out the answer from the smallest value to the largest value. Okay. Yeah, so this is the answer for the value of x. Okay, so we come to question number 6. We are having the function f, which is defined by this, and then the domain given is x smaller than 3. They want us to express this function in this pattern, in the form of completing square. Alright, so we will start. To completing a square for a quadratic equation, you need to factorize out the coefficient of x squared first. So I'm having x squared minus 8x. And after that, I have to plus something square, then minus something square. And what is the something in our step here? The something here will be generally the negative 8 divided by 2. So I'm having negative 4. So plus negative 4 square minus negative 4 square. And then for the constant term, I don't want to disturb it, so I will just keep it as plus 23. Okay, so let's observe all the terms inside. I'm going to factorize these first three terms into a big bracket where I'm having x minus 4 and then square. So if you don't believe, you can try to expand this particular bracket and you'll get back the three terms here. Alright, then I'm having minus 16 plus 23. Multiply the 2 inside every single term for the bracket. And I'm having 2 x minus 4 squared minus 32 plus 23. And therefore, if I further simplify it, I will have 2 x minus 4 squared minus 9. This is a completing square formula for a quadratic function, right? So this is our part A. And now we proceed to part number B. Part number B, they want us to find the range of f. Okay, so to find the range of f, basically you need to have the idea how the groove looks like for this particular curve. For this particular curve, according to what we have here, we know that the vertex is basically x equals to 4 and then y equals to negative 9. And because of this value, it is positive value, therefore it should be a U-shape. U-shape's vertex will be this point where it is a minimum point, which means that we are having a coordinate of minimum point at 4 and negative 9. If we try to further sketch out the diagram, it might look something like this. Okay, maybe for me, I just simply draw out. I didn't go and have a look for the detail for all the x and y axis. So basically, I might have something like this. Okay, and I will try to label that this is particularly a 4, and then this value is actually negative 9. Okay, so this is my function fx. But for this particular question, because they have restricted our domain, where they want us to consider only for the value x smaller than 3, therefore, when we want to get the range for this particular function, right, I have to see what is the value of 3. When I substitute the value for 3, what is the value of y that I get for this particular function? Okay, which means that I need to find out the value for 3, and for this x smaller than 3, we only consider this highlighted graph. For this highlighted graph, if you get the range, basically it is from here until here. Okay, yeah, so I will continue the step by substituting the function, the value 3 into our function. So I will substitute 3 into our function f. Okay, so for f3, I will get 2 and then 3 square minus 16, 3 plus 23. Or you can straight away substitute into the completed square form, also can. And then if I try to simplify this value, I will have negative 7. Which means that if I go back to the diagram here, this particular value is negative 7. And my range for this part of the curve, right? The smallest value is negative 7 and it will keep on going up until positive infinity. Therefore, when I write out the range for the function, I can write out in this way, where y is greater than negative 7. So this is how we find the range for f. Then we go to part C. For part C, they are asking us to find the expression for f inverse x. Basically, when we are having a quadratic equation, to find out the inverse function, the only way that we need is the completing square form. And just now we already get our completing square form. I will let y equals to this completing square form or completed square form. And now my aim is to rephrase my answer x in terms of y. So I try to move all the terms slowly to one side, and I just want to make sure that I keep the x on the left. Okay, wait, so when I want to take square root, I will have plus minus square root y plus 9 divided by 2, and after that I'm looking for 4 plus minus square root y plus 9 divided by 2. Okay, so for the steps that we are having here, right, basically we are having two answers for the inverse function. First one is 4 plus square root something. Another one is 4 minus square root something. So which one is the correct inverse function that I should choose? Okay, so please take note that all these are basically the range for the inverse function. All the formula here are actually the range for the inverse function, and it should be equal to the domain of the function. So this is a special rule that you need to know according to the understanding of the domain and range of function and inverse function. Alright, so since we know that the range of inverse function should be equal to the domain of the function, and our domain of function is x smaller than 3. So by referring to x smaller than 3, we should ask ourselves, 4 plus something will get smaller than 3, or 4 minus something will get smaller than 3. So I think definitely this one, right? If we have 4 plus something, it will always greater than 4, where it is impossible for us to get a value which is smaller than 3. Alright, so this is how we decide it. Therefore, let's get the inverse function. So the correct inverse function will be 4 minus, I will change all the function in terms of x. So I'm having x plus 9 divided by 2. So this is how we get the inverse function for the function f. And now let us proceed to part D. For part D, the function g is defined by 2x plus 4 for this domain. They want us to find and simplify an expression for f gx. This is a composite function basically. Alright, and then I just want to recall back my function fx just now. So my function fx just now, if I want to use the completed square form, I will have this as my function fx. Okay, and then now let us start our composite function. So when I'm having f gx, that means I'm going to substitute the function gx into the function f. This is my function gf, which is gx, which is 2x plus 4. I want to substitute 2x plus 4 into the x in my function f. If I substitute it, then I will generally get 2x plus 4, then minus 4, and square minus 9. So further simplify this, plus 4 and minus 4, I get a 0. So I'm having 2x squared minus 9. And further simplify it, I should have 4x squared minus 9. sorry, it should be 4 times 2. Basically, this one should be the 8. 8x squared minus 9. Of course, if you want to substitute into the original function provided by the question, the function f, right, also can, just that maybe the steps to simplify it will be slightly longer. Alright, so since I can observe that there's a plus 4 and negative 4 in the function, and then I'm substituting the gx into the function fx. Okay, so this is how we solve question number 6. Okay, so question number 7. The diagram shows the circle with this equation and then with a center C. So C is the center basically. So from here, I think we can straight away get the coordinate for C lah. Alright, so from here, x minus 2 equals to 0, I get x equals to 2. And then I let y plus 4 equals to 0, and I get y equals to negative 4. So the center coordinate basically will be 2 and negative 4. Alright, so this is the first information that we get from this question. And they are saying that the point B has this coordinate 0, 2, and the line segment BC intersect at the circle at P. So first they want us to find the equation of BC. Okay, so to form the equation of BC, basically I need a gradient. And also a passing point. So I need to find the gradient first. For the passing point, you can use the point B or point C later, right? Since we are having the coordinate for 2 points already, so passing point is not a problem for us. Okay, so let's try to find the gradient first for BC. Okay, so to get the gradient for BC, I need to use the formula where y1 minus y2 equals to x1 minus x2. C is 2 and negative 4, right? So I will use y1, maybe negative 4 minus y2, which is a 2, divided by x1 minus x2, so 2 minus 0. Okay, so if I try to simplify my gradient, I should get negative 3. And to form the equation of BC, I'm using this formula y minus y1 equals to mx minus x1. You can use any coordinate for B and C that you like, either B or C, up to you. For me, I'm using point B as there's a x coordinate 0. So y minus 2 equals to negative 3, which is a gradient, and then x minus x coordinate is 0. And if I further simplify it, I should get y equals to negative 3x plus 2. This is the equation of BC that we can get. Right, then now proceed to the second part. Okay, so for part B, they want us to find the coordinate of P, giving your answer in the exact form. To find the coordinate for P, basically you should know that it is the intersection point between the line and the curve, right? If you have a look for the diagram again, so P is actually the intersection between the line BC and also the circle. So to find out the intersection point, what we need to do is we need to solve these two equations simultaneously. Okay, so again, my original curve equation is x plus minus 2 squared plus y plus 4 squared equals to 20. This is my circle equation. And my equation of BC is basically y equals to negative 3x plus 2. So I will want to substitute equation number 2 into equation number 1. So when I try to substitute it, my equation will look something like this. Y will be negative 3x plus 2 and then plus 4 squared equals to 20. So from here, I would like to expand it. So I'm having x squared minus 4x plus 4. I'm having 9x squared minus 36x plus 36. And that equals to 20. Okay, so to expand this one, please make sure that you add 2 and 4 together first. So you're having negative 3x plus 6. Then after that, only you expand it. Okay, so further simplify this whole equation, I will have 10x squared minus 40x plus 20 equals to 0. Then again, we can further simplify one more time. Right. So now, for this quadratic equation, basically we can't factorize it, right? So what we need to do is we have to apply the quadratic formula, where to get the value of x, it is negative b. So negative 4. Our b is negative 4, right? Okay, so maybe I label it. This one is the b, and then 1 is the a, and 2 is the c. So we're having negative b plus minus b squared minus 4a and c divided by 2a. Okay, so simplify it. I'm having 4 plus minus square root 4 square. Negative 4 square is 16. So 16 minus 8 divided by 2. Next step, I'm having 4 plus minus square root 8 divided by 2. Let's simplify the square root 8. I'm having 2 square root 2 divided by 2. So every single term here divided by 2, I will have 2 plus minus square root 2. Okay, but of course I need to know which one actually belongs to P and which one belongs to the next intersection. Because by right, if the line, if we extend the line, right, the straight line, you can see there are two intersection points. So we should take a smaller value as a P. Okay, so let us have a look for the diagram again. If we try to extend the line, you are having two intersection point here. So that's why in this part just now, we get two values for the x coordinate. And then if you try to compare, P is actually has a smaller value for x coordinate, and this second intersection point is having the larger, alright, it's having the larger value for the x coordinate. Therefore, from here, you can decide that the x coordinate for P is actually the smaller one, which is 2 minus square root 2. Okay, and after that, of course, I need to get the value for y. So to get the value for y, it is negative 3x plus 2, right? The equation of BC just now, because P also lies on the equation BC. So to get the y, I think it is easier that you substitute into the equation of BC. Right, so when you simplify from here, I will have negative 4, then plus 3 square root 2. And we have to leave our answer in the exact form. So this is basically the coordinate for P, where it is 2 minus square root 2, and also negative 4 plus 3 square root 2. Okay, so this is basically how we solve the question number 7. Okay, so we come to question number 8. They give us a diagram, and then it shows the curve with this equation, and then there's a line y equals to 5, and the line y equals to 5 intersect the curve that these 2 points are A and B. So you can see from the diagram here. So first question, they want us to find the equation of the tangent to the curve. Equation of the tangent to the curve at the point A. Okay, so to form the equation of tangent to the curve, basically I need to find out the gradient of tangent first. To find the gradient of tangent, we basically need the differentiation of the equation. So I'm having y equals to x power half plus 4x power negative half. And then when I try to get the dy dx, basically it will be, okay, so we differentiate the term. Right, dy dx later will be our gradient of tangent. So we differentiate the term first. The power half, put it in front, become half. Copy the x, power minus 1 become negative half. 4 is a constant, I just copy. Power again, I bring it in front, I'm having negative half. Copy the x, then the original power minus 1, so I'm getting negative 3 over 2. Okay, then we try to simplify it. I'm having 1 over 2 square root x, and then minus 2 over x power 3 over 2. And then at point A, what is the coordinate for point A? I'm having 1 and also 5, right? So we substitute x equals to 1 into my dy dx. when I substitute x equals to 1, I'm having negative half. Sorry, I'm having half minus 2. And the gradient of tangent that I get here will be negative 3 over 2. Okay, so you should know that when I'm having the dy dx and substitute the particular x coordinate for the point, right, the value that we get is the gradient of the tangent. This is gradient of tangent. And then for a curve, there are many gradient of tangents, right? So this is actually the gradient of tangent at point A. Okay, so since we are having the gradient already, and we also have the coordinate for the passing point, which is the point A, we can form the equation of tangent. Get the equation of tangent, again, I'm using the formula y minus y1 equals to mx minus x1. So y minus y1 will be y minus y1 is a 5 equals to negative m, and then x minus x1, so x minus 1. Okay, so if I try to further simplify, my final answer for the equation of tangent will be negative 3 over 2x and then plus 13 over 2. Right, so we need to apply the differentiation first to get the gradient of tangent, and after that form the straight line equation. Then now we proceed to part B. So for part B, they want us to calculate the area of the shaded region. Okay, so to get the area for the shaded region, basically you will see that this shaded region is covered by line and the curve. It is bounded by the line and the curve. So you can see that the upper line that bounded the area is the line y equals to 5. And then the lower graph that bound the area will be the curve equation. So later when we want to find out the area under the graph, we can find out the area for y equals to 5 first under the graph, and then integrate and then minus the area created, okay, by the area the area created, the area under the graph created by this one, x half plus 4x power negative half. Okay, so another way is you can straight away take the function above minus the function below, and you integrate from the limit so that you can get the area bounded also can. Alright, so we will start. So for me particularly, what I'm doing here is I will take the equation on top minus the equation at the bottom. So from the diagram just now, I can see that the area bounded start from 1, then end at 16, right? X equals to 16. Then the upper function is 5, y equals to 5, then minus the lower function. So for the lower function, it will be x power half plus 4x power negative half, and then dx. Okay, so to avoid careless mistake, I think I will try to multiply in the negative first. Okay, so I can start the integration. 5 is a constant, If you integrate, you'll get a 5x power 1. X power half, you take the original power divided by 1, plus 1, so you have 3 over 2. Then you divide it by a new power 3 over 2. Copy the constant 4, take the old power negative half plus 1, so you get positive half. Then you have to divide it by the new power half. Okay, then I will want to substitute my limit 16 and 1 into the value of into the x later. Okay, so before I substitute the limit inside, what I prefer to do is I will try to simplify everything first. So 4 divided by half, you'll get an 8. Then I'm having 16 and 1. I will now want to substitute 16 into the expression here. 5 times 16, I got 80. Then substitute 16 into the second term and simplify. I will have 128 over 3. 16 substitute into the third term, I will have negative 32. and now minus the whole part when I substitute the value x equals to 1. So substitute 1 here, you'll get a 5, then negative 2 over 3, and also negative 8. Then if you try to simplify it without any careless mistake, the answer that we get should be area equals to 9. This is one way. Another way is some of us might want to use the area under the graph for y equals to 5. So you can see the area under the graph for y equals to 5 is a rectangle. So some of the students might want to use the area of rectangle, then minus the area under the graph for the curve also can. Okay, so to get the area of the rectangle, you know that the height is basically a 5, and then the value here you can take 16 minus 1, where you get 15. Okay, so another option step or alternate step for this question is you can use the area of rectangle. You can also use the area of rectangle minus the integration of 1 until 16 for the curve function. So the curve function will be x power half, then plus 4x power negative half dx. And like what I showed you just now, the area of a rectangle is the height times base. So the height is 5, the base is 15, right? And you can integrate this part where x power 3 over 2 divided by 3 over 2. Same thing happens for the second term, divided by half. Then you substitute in the limit for 16 and 1. And from here, I will have 75. Again, before I substitute the value in, I will want to simplify my equation first. So from here, first of all, I substitute the limit 16. So when I substitute the limit 16, I will have 128 over 3 and also 32. Then minus, substitute 1, you have 2 over 3 plus 8. Okay, so if you try to simplify also, the final answer should be equals to 9 as well. Okay, so both methods are correct, and let's see which method you can understand better. Right. Okay, so this is how we answer question number 8. Okay, we are now at question number 9. We have a triangle, or we have a diagram here, and then they are saying that the triangle ABC is having AB equals to BC equals to 6, and the angle ABC is 1.8. Then the arc CD is a part of the circle with the center A, and also ABD is a straight line. They want us to find the perimeter of the shaded region. Okay, so to find the perimeter of the shaded region, I already have the length for this side, which is BC. I need the length for BD. To get the length for BD, I need to find out the length for AD, so that I can take AD minus 6 to get the length for BD. And for this AD length, it should be the same as AC, because the sector is actually the part of a circle, right? Okay, so now I'll focus on to find out the length for AC first. To find the length for AC, I will use the cosine rule for the triangle, where the cosine rule, if you write it out, it will be AC squared equals to 6 squared plus 6 squared minus 2 BC, right? So 6 and 6 cos theta. And because AC is not my final answer, therefore for me, I will keep it in the exact form. I take square root, then I will have 72 minus 72 cos 1.8. Right, because the theta here is 1.8, as we can see. The theta is 1.8. Alright, okay, so our AC will be square root 72 minus 72 cos 1.8. And after that, besides the length for AC, I also need to find out this one, the arc of CD. To get the arc of CD, I need AC length, which I already have it just now, and also I actually need this theta, this angle. To get this angle, basically, you can use a simple rule in a triangle. That means when we are having a triangle, right? So the total angle inside will be pi, which is 180. Then minus 1.8 minus the angle that we have here, and I divided it by 2. Okay, so the angle DAC is pi minus 1.8 divided by 2 because of we are having a not to say equilateral triangle, isosceles triangle. Okay, so when you're having the isosceles triangle, basically you know that this value and this value should be the same. They're having the same angle here. Alright, so our angle DAC equals to this value, and I will also keep it in the exact form because this is not my final answer yet. Right, so now I can start to combine everything together so that I can get the length for all the parameter for the shader region. Right, so for the parameter of the shader region, you can see that we need BC, we need BD, and we need CD. Okay, so let's start. To find out the parameter, we need the length of CD plus CB plus BD. Okay, so to get the length for the arc CD, basically it is r theta, and the r is actually AC, the length for AC. So I'm taking r, which is square root 72 minus 72 cos 1.8 multiply with theta. So the theta is actually this angle, which is pi minus 1.8 divided by 2, and this is what we have for CD. To get the value for CB, it is a very straightforward value, which is a 6 because the length is provided already. And then I need to get the length for BD. To get the length for BD, I will take AD divided AD minus 6. So I'm having 72, then minus 6. Okay, because AD and AC are having the same length. Therefore, I'm using the length of AC, then minus the 6 to get the length for BD. And then from here, if you try to simplify everything in detail, then you should get your answer, which is 15.7. Right, so this is how you solve question number 9, part A. And let's proceed to question number 9, part B. They want us to find the area of the shader region. To find the area for the shader region, if you go back to the diagram again, so you can see that we actually take sector minus the area of triangle. Alright, so we have to take a sector minus the area of triangle to get the shaded area. Alright, so maybe I can write my answer here so that you can see very clearly. Okay, part B. I want to get the area of the shaded region. I will need sector area minus the area of the triangle ABC, right? Okay, so what is the sector area? So the sector area will be half r squared theta. So half I just copy as a half. What is the value for the r squared or r? R basically is the length of AC. Therefore, I'm having square root 72 minus 72 cos 1.8. This is my r, and then I have to put a square. So this is half r squared theta. And the theta is the angle that we found just now. This one, which is pi minus 1.8 divided by 2. Okay, so this is half r squared theta, which is the area of a sector, minus the area of a triangle. To minus the area of the triangle, you can use the formula for sine, right? Which involves the sine. I'm having half, then AB sine C. So I want to use two sides here, which is this side and also this side. So AB sine C means I'm having 6 times 6, and then sine the angle covered by the two sides, which is 1.8. Alright, so again, try to simplify all the terms here by using the calculator and simplify. Your final answer for area for the shaded region will be 12.1. Right, and then for a small reminder here, when you want to press calculator and get the value, right, we are having cos 1.8. The 1.8 is in the unit of radian. Okay, and also when you're having this one sine 1.8, therefore please ensure that you put your calculator in the radian mode when you are trying to use calculator and get the final answer. Alright, it must be in the radian mode because of the angle that we are using here are all measured in radian. Of course, if you can change it become degree, then you use the degree mode in your calculator, also no problem. Alright, so this is how we solve question number 9. So we come to question number 10. Okay, so for this question number 10, we are given a function f(x) for x greater than negative half. They want us to find the integration from 1 until infinity for the f(x) function. Okay, so for the integration, this one you call it as an indefinite integral. Okay, or we can call it as improper integral as well. Alright, so I want to find out the integration for this function. Okay, so first of all, I will want to substitute the limit infinity by using a letter. So maybe I can put it as a letter A, and I want to let the limit of A goes to infinity. Therefore, my question will become integrate from 1 until A for this particular function. Okay, so for the next step, basically we can start the integration. I'm having a bracket with a power. Therefore, I can integrate by copying the bracket power plus 1, where I will have negative 1. So divided by the new power negative 1, differentiate the 4x plus 2, you get a 4. I also need to divide my term with a 4. Then I want to put in the value A and also 1 into my answer. Alright, so before I substitute the value inside, I would like to factorize out the constant first. I keep the limit A to infinity, and then I'm having 1 over 4x plus 2, A and 1. Okay, so let's substitute the value for A and also the 1 into our expression here. I'll have 1 over 4A plus 2, then minus 1 over 4 plus 2, which is 6. And now we are trying to substitute A infinity inside our fraction. So if you have a look at 4 times infinity plus 2, it will be still a very large number, which is still an infinity. So according to what we have here, we are having 1 over infinity, where infinity should be a super large number. When we have a value that is divided by a super large number, this value will getting very, very small, and we assume that it is very, very close to 0. Alright, therefore, my next step will be I'm having still negative 1 over 4, then I will have 0 minus 1 over 6. Simplify further, and therefore, this is the answer that I get, where I will have 1 over 24 for the answer. Okay, and now let us proceed to part B. Okay, so for part B, what we are having here is we have a point moving along the curve in such way that it passes through the point A, the y coordinate is decreasing at the rate y decreasing at the rate of k. That means for this particular sentence, if I try to convert it into a symbol, it will be dy over dt, and it is equals to negative k. So the negative is needed here because of the word decreasing, and then the rate is a k. Right? So this is the information that I can get from the first sentence here. And after that, they are saying that the x coordinate is increasing at the rate of k units per second. So for this particular phrase also, if I try to rephrase it into a formula or maybe into a symbol, the x coordinate increasing at a certain rate, right? So it will be dx over dt over the time. It is equals to positive k because of the word increasing. And now they actually want us to find out the coordinates of A. Okay, Alright, so to find out the coordinate for A, basically we need to use chain rule, because in this question we are having dy dt, we are also having dx dt, and the function fx is actually given just now. This is my function fx. Alright, therefore to solve this question I need to find out dy dx first. I want to find out dy dx so that I can apply chain rule and further to get the coordinate of A. Okay, so I will start with the differentiation first. I'm having y equals to, from part number 1, right, our function f is, what is it? Is 4x plus 2 minus 2. Okay, I try to get the differentiation first. Dy dx will be equals to, bring the power in front, copy the bracket, power minus 1. And you differentiate the thing inside the bracket, you get a 4. If I further simplify it, then I should have negative 8 over 4x plus 2 power 3. Okay, so now these are all the information that I have for now. Okay, and I want to find out the coordinate A by applying the chain rule here, because I'm having all the information about the chain rule. Okay, so I will let dy dx equals to dy over dt multiply with dt over dx. Okay, so when having dy dx, I'm having negative 8, then divided by 4x plus 2 power 3 equals to negative k multiply with dt dx. Dx dt is k, so dt dx will be 1 over k. And from here, you'll get it equals to negative 1. And I think it is quite obvious. You can try to solve this equation to get the value for x. That means when x is equal to this particular value, right, that we find out, the chain rule equation here basically is a true one, right? So that also means that the x is actually the x coordinate for the A, for the point A. Because I'm mentioning that for point A, your dy dt and dx dt value is shown like this. Okay, so if I try to continue and get the value for x, I will have 2 minus 2, then divided by 4, and I get the value of x, which is 0. And after I get the value for x, which is equals to 0, I will substitute x equals to 0 into my y equation. When I substitute into my y equation, basically I get 1 over 4. And this is the coordinate for the point A, that we are having the rate of change for the y and x, okay, which is equal to negative k and also the k. So A is equals to 0, comma, then 1 over 4 for the y coordinate. And now we come to the very last question, question 11. You're having the point P lies on the line with this equation, where the m and c are positive constants. Okay, a curve has this equation, y equals negative m over x. There's a single point P on the curve such that the straight line is a tangent to the curve. So usually when I see there's a straight line is a tangent to the curve at P, right? The first thing come to my mind is I might want to use the discriminant result where b squared minus 4ac equals to 0. Okay, so this is what come to my mind when I see all these keyword here. Okay, but to get the b squared minus 4ac equals to 0, right, I need to have a quadratic form equation. And from here, you won't see any quadratic form equation. And we know that we are having the straight line, which is y equals to mx plus c, and also y equals to negative m over x for the curve. And then this one is actually like we are having the intersection point between the straight line and also the curve, right? So to solve, we are going to think in a way that, to solve and get the intersection point, I need to solve these two equations simultaneously. I'm having mx plus c equals to negative mx. So hopefully after this step, maybe eventually we'll get the quadratic form equation. Then we can apply b squared minus 4ac equals to 0. Okay, so I will start from here. I will let straight line equation equals to the curve equation. Then trying to solve for to rephrase the equation. Okay, I don't like the x as a denominator, so I bring it up. And then if I try to simplify it, I rephrase it, I will get actually a quadratic form equation. So you can see very clearly that this is a quadratic form equation. And since they are saying that the straight line is a tangent to the curve, and we are having a quadratic equation now, we can use b squared minus 4ac equals to 0. And what is my b squared? It is actually the c here. The coordinate, the coefficient of the x. So it is c squared minus 4. What is the a? A will be the m. And then c, what's the value for c, which is also the m, the constant term. It is equals to 0. Okay, so from here I'm having c squared minus 4m squared equals to 0. And everything here, right, you can see that we can put it into the square form, where you can further factorize it, becomes c minus 2m and also c plus 2m equals to 0. And I'm having c equals to 2m, c equals to negative 2m. For this particular answer, c equals to negative 2m, I will ignore it. We can straight away ignore it, because if you have a look again for the question, they are saying that m and c should be positive constant. If c is positive and n is also positive, then this equation will not be true, because c, the positive value, cannot be equal to negative. The negative is here, right? And then m is positive, so it is impossible that, oh, this positive value equals to a negative positive value. So we ignore this equation. That means this is the equation that we have for now. C equals to 2m. And then this is, of course, not the constant or anything, right? Sorry, it is not the x coordinate or y coordinate for any point, right? We actually want to find the coordinate. So this value, this equation, maybe temporarily I will make it as equation number 1, where I know that c is equals to 2m. Alright, then if we continue further, when you go back to the question, they want us to find the x coordinate of p. The coordinate of p. Maybe we can start by looking at the x coordinate. This is the quadratic equation that we have, right? So to get the value for x, you can apply either factorization, or for this case, you can only apply the quadratic formula. So I will want to find the value for x by using the quadratic formula. X equals to negative b plus minus square root b squared minus 4ac. Then divided by 2a, so which is 2m. Okay, then now let's have a look for this particular term here, c squared minus 4m squared. This one is equals to 0. Why? Because it is actually the b squared minus 4ac. C squared means b squared, right? Minus 4, a is a m, c is also the m. Therefore, I know that this value is a 0. And I can just focus on simplifying my answer here, negative c over 2m. And to get the x coordinate, right, I have a value or relation or equation that is linked between the c and m. So I know that c equals to 2m. So what am I going to do here is will be negative 2m divided by 2m, and the x coordinate will be negative 1. Okay, after I get the x equals to negative 1, then I can substitute it into the line equation. So where's the line equation? This. Okay, to get the y coordinate. So I'm having y equals to mx plus c. M is a m, x is negative 1, and again, what is the value for c here? Just now we have the first equation, c equals to 2m, right? So you just add them with 2m, and your y coordinate that we get here will be the m, which means that the p has a coordinate of negative 1 and also m. So this is basically how we solve this part A. Alright, so if you have a look for the question again, they are saying that find the coordinates of P giving the y coordinate in terms of M. So you can try to observe your answer again. Our x coordinate is a number. Then they only mention the y coordinate is in terms of m. So I think our answer should be correct. Alright, fulfill what the question was. Okay, so this is what we have for part A. Our P is actually -1 and m. Okay, then we can proceed to part B. Just now they are talking about the line is a tangent to the curve. And now they are mentioning that we are having a normal to the curve at also point P, intersect the curve again at point Q. So you know that for this question, right, they are talking about the normal. So the normal, we have the passing point. The normal pass through the point P. Okay, and point P, just now we have -1 and m. Okay, this is the coordinate for P. Okay, then we are talking about the normal in this case, right? And just now we know that y equals to mx plus c is basically the tangent. Okay, tangent to the curve. So the gradient of tangent is basically equals to m. And now I want to use it in our part B. Okay, all right, so let's start. We are interested to find out the equation of normal. Therefore, I need to find out the gradient of tangent first. So from part A, I know that gradient of tangent is equals to m. Since we are interested to find out the normal, we can use the property where normal gradient times tangent gradient equals to -1, right? So for this one, the gradient of normal should be equals to -1 over m. And since I know also I'm having the passing point P, okay, this is the normal at the point P, I can form the equation of normal. To get the equation of normal, I'm taking y minus y1 equals to gradient of normal -1 over m, and then x minus x1. So minus -1, I get x plus 1. Okay, expand everything. I will get this as a equation of normal. Then again, they are saying that the equation of normal intersect the curve again. Alright, so I want to let equation of normal equals to the equation of the line so that I can solve them simultaneously and see what's the coordinate for Q. So I let equation of normal equals to the equation of the curve, -m over x. Okay, so I try to simplify slowly. First step, what I want to do here is I want to make the negative x, the x disappear as a denominator. Therefore, I multiply the whole equation with x. So I'm having -1 over m x squared minus 1 over m x plus mx, then equals to -m. So this is the first step that I try. Then the second step is I want to make the 1 over m no more denominator. I multiply the whole equation with m. So I will have -x squared minus x plus m square x equals to -m squared. Okay, so I want to rephrase my whole equation now slowly. I will have x squared. Okay, so I move everything over first. So I will have x squared plus x minus m square x squared, which is equals to 0. And then I will want to rephrase it into a quadratic form equation. Okay, so this is actually what I have for the quadratic form equation. And then to get the x coordinate for this quadratic equation, I can also apply the quadratic formula. So I will let x equals to -b plus minus Okay, then b square minus 4ac and divided it by 2a. So 2a is a 1. Alright, so next step, of course, you need to expand and simplify the thing inside the quadratic, inside the square root. Okay, if I try to expand, so expand the b square, I'll get this, then plus 4m squared divided by 2. Okay, again, factorize it further, simplify it further. I will have m power 4 plus 2m squared plus 1, then divided by 2. Next, it can be factorized for the term inside the square root. So I'm having m squared plus 1 squared divided by 2. Okay, so from here, I think I will try to separate the answer out. I'm having plus m squared plus 1 divided by 2. After I take a square root, right? So the square disappeared. And then another answer would be m squared minus 1 minus m squared plus 1 divided by 2. Okay, so of course I need to continue to simplify these two answers here. So to simplify these two answers, basically we will have 2m squared divided by 2. And after that, we are having this part, which is negative 1. And when you see the negative 1, this is actually point P, right? And we are interested to look for point Q. Okay, so I will have m squared, which is the x-coordinate for point Q. Okay, so after you have the x-coordinate for point Q, substitute it into your normal equation. And your normal equation is this one. Okay, substitute inside. I'm having negative 1 over m squared for the x. Okay, then minus 1 over m plus m. If you try to simplify this, I will have negative 1 over m. And this is the y coordinate for q. So from here, we are having q m squared and also negative 1 over m. Okay, so basically this is how we actually get the answer for 11 part B. Okay, so we have ended discuss this paper. Alright, thank you very much for watching the